Number three, we're asked to do some basic manipulations of some degrees and radians. So this first one, you have 1,800 degrees, and you want to convert that to radians. Um, so I have my 1,800 degrees, and remember there's a conversion factor, which is pi over 180 degrees. That'll cancel out. 180 will cancel with this and leave you with a 10, so I just end up with 10 pi, and that's radians. Okay, this one asked me to convert from radians to degrees, so use your conversion factor, but now you flip it over. And so the pi's cancel out. 10 cancels out, leaves you with 18. So canceling a pi, let me change colors here, it might make it a little clearer. Cancel the pi. I can cancel out this and leaves me with 18. So I just get 36. And it'll be degrees. And part C says find two angles that are coterminal with 200 degrees. So just to get our bearings straight, 200 degrees, that's 180. So that's 20 degrees past here. Well, so I could go backwards to get to it. If this is 200, then I'd have to go backwards 160 because this is a total of 360. So one angle that's coterminal with that would be negative 160 degrees. And then probably the next best way would be to go all the way around 360 and then go another 200. So that would be 360 plus 200 would be 560 degrees. So that's two angles coterminal with that. And then this last part on number 3 says find one angle that's coterminal with minus 4 pi over 5. So kind of again thinking where that is, if I would have gone all the way backwards minus pi, that would have got me to here, but this is a little less than that. It's actually pi over 5 less than that, because that would be 5 pi over 5. So I'm going to stop short where this measurement inside here is pi over 5. That would be my negative 4 pi over 5. So I'm saying this is pi over 5. So if I want one that's coterminal, I just need to come this way, going pi over 5 past pi. Well, again, this is 5 pi over 5 going pi over 5 past that would get me to 6 pi over 5. So that's certainly one way to do it. Another way to do it would be spin around, go past it, and then come back to it. And all you do there, and you weren't asked to do two of them, but I'm just showing you another option, is you go minus 2 pi, that brings you all the way around back to start, and then another minus 4 pi over 5, that would be another coterminal. And then you can find a common denominator. This would be 10 pi over 5, which would be what, negative 14 pi over 5 would be another option there. And there's infinitely many more, but that's kind of the two basic ones. All right, and then this last one on this page, we're told that tangent of theta is 5 over 3, and that sine is negative, and we're asked to find the values of each of the other 5 trig functions. So let's see, I've got sine theta I got to figure out, and cosecant theta, and cosine theta I need to figure out, and secant theta. Tangent theta I don't need to figure out, it was given to me, and cotangent theta. All right, so given this information, I can tell you what quadrant this is in, because tangent is positive 5 over 3, and sine is negative. Well, we know that would happen in quadrant 3, because sine is positive in quadrant 1 and 2 and negative in quadrant 4, but tangent's negative in quadrant 4. So the one where you have this combination would be quadrant 3. And I need to know that because I do have to put the appropriate sign on all my all my trig values down here. Well, this one is simple enough. You just flip it over. That's the reciprocal identity. To get the other ones, I'm going to draw the triangle, knowing that I'll then put the proper sign on each of these. So we'll draw the triangle that gives me tangent equal to 5/3. And then by the Pythagorean theorem, I'm going to get, oh, this was supposed to work out nicer. I'll change these numbers so that you get nicer values. This is 4/3. Sorry. I just did it in my head. So this would be a 4 over here. And then that makes this one 5. I was trying to get you a 3, 4, 5, and I put the wrong one down. Anyway, so this would be what you'd get. And so like you can see, cotangent is adjacent over opposite, but we already got that one. But I can get the other values up to figuring out the plus or minus sign. So let's see, sine is opposite over hypotenuse. We'll put them for now. And this would be then the reciprocal of that, 5 over 4. And then cosine is adjacent over hypotenuse. That's 3 over 5, and this would be 5 over 3. And since I'm in quadrant 3, the only two that are positive are these two. So these all have to be listed as negative. Negative doesn't look so great. But anyway, another way to have done this would have been to say you've got an angle that we know is in quadrant 3, and I could draw my triangle like this on the axes and say this is 4, this would have to be, this would have to be negative 4 and negative 3, and then this would still be 5. Using these negative values, you can see now I could just do opposite over hypotenuse to get my negative 4/5 for sine, and then I could do negative 3 over 5 and so forth. I mean, there's different ways of doing it. Once I know what quadrant I'm in, all I have to do is figure out the value and then put the plus or minus sign in front based on that quadrant.